All right, hi everybody. Today we are going to talk about special right triangles. There are technically two special right triangles, and what special right triangles are um, triangles that have specific measurements of their angles that make their sides have specific relationships. Um, so it goes along with SOHCAHTOA. All this is going to get kind of rolled in together, especially in Math 3 when you really start using SOHCAHTOA and special right triangles to kind of launch into more trig. Um, so they're not necessarily, you're not going to see me do SOHCAHTOA today, um, but you could if you wanted to. So don't feel like this is out of left field. Um, just know that this is another special triangle relationship. SOHCAHTOA is also triangle relationships, right? Setting up the proportions, excuse me, and everything. So we're going to start with 45, 45, 90s today. And they're called 45, 45, 90s because this relationship happens when you have a right triangle, so that's the 90, and then the other two angles are 45 degrees. So that's why we call it a 45, 45, 90. Um, and obviously we know that works out because the angles of triangles add up to 180. So going back to Math 1, if you remember, um, when you have two angles that are the same, their opposite sides are also going to be congruent. So if those angles are congruent, their opposite sides are congruent, meaning if this angle at the top here is 45 degrees and the side across from it we call x, this angle down here on the right that is also 45 degrees also has to be x because they are going to be the exact same. So in a 45, 45, 90, you're always going to have an isosceles triangle, which means two of the side lengths are equal. Now, how do we find this third side length, that hypotenuse? Well, we're going to rely on the Pythagorean theorem, okay? But I'm not going to do it with numbers. I'm going to use my variables. So I am looking for this side right here, which means if I were to set up the Pythagorean theorem, I would have x squared plus x squared for my a squared plus b squared for my legs equals whatever that side is squared. Okay, so I'm looking for that hypotenuse. Well, if I go to solve for that question mark, x squared plus x squared means it's 2x squared, right? X plus x is 2, it's just combining my terms. So x squared plus x squared is 2x squared. And that equals that side I'm looking for squared. Well, in order to get that question mark by itself, I'm going to square root both sides. Okay. Now, think about this. Right now, I am saying that the square root of 2x squared equals that missing side. However, remember, we always want to simplify our radicals. 2 is not a perfect square, but x squared is. You guys remember this is x times x. So this is going to come out of the radical as its square root, which is x, which means I have x radical 2 for my missing side. Okay. If you have any trouble seeing this x squared coming out, remember when we have something like the square root of 16, the 16 comes out as a 4 because that's 4 times 4. So the 4 comes out. So if you have the square root of x squared, that's x times x, which is why the x is coming out. Okay. So if you look in this box, okay, this is a 45, 45, 90. And I'm just going to put all of the angle measures and then all of the side relationships on it so we know exactly where to go. This side right here is x. This side will also always be x, and the hypotenuse will always be x radical 2. So the relationship there is you could always take the legs and multiply them by radical 2 to get the length of the hypotenuse. Conversely, if you are given the hypotenuse and you need to find the legs, we would just divide by the square root of 2 to get solve for x. Okay, so I'm going to show you how to do that down here. I just have a couple examples. There's only so much you can do with these. The biggest thing on some of them is going to be watching your algebra. So here, it says find the measures of the missing sides below. So if you look, we have a 45 here, which means because of that right angle, this is an implied 45 as well. You don't have to write it in, but I like to. The first thing I always do is I label my sides. So I know that this side is x, this side is x, and this side is x radical 2. Okay, and I always put those labels inside. And then you look and see, okay, the one side I know is kg. Well, kg is 4 inches. It's also one of my x sides. That tells me that x equals 4. Okay, well, if x equals 4, that means this side right here, which is also x, is 4. And then to find my hypotenuse, I just take those sides and multiply whatever x is by radical 2. So this is 4 radical 2. All of these are going to stay exact. You will not do decimals for any special right triangles because you are using the relationship to keep your life easy. So GE is 4 inches and KE is 4 radical 2 inches. I know typically in the past I've had you do a decimal for that, but for this, when it's a special right triangle, just leave it as is. Okay. And if you look at number 2, we have 45 here, so we also have 45 here. Okay. And then I go through and I label my measurement, or my relationships, excuse me. This is x, this is x, and then my hypotenuse is always x radical 2. The side I'm given this time is the hypotenuse. So that tells me that the side that is x radical 2 is equal to 6 radical 2. Well, your goal in all of these, and especially for the next lesson when we do 30, 60, 90s, is to solve for x. If you can solve for x, you can find all of the sides. In this case, it's a little easier. The next one, there'll be a little bit more involved. But in trying to solve for x, I'm going to divide by the square root of 2 on both sides so that these cancel out. So now I know x equals, well, they would cancel out here too, and that would be 6, meaning this side is x, so that is 6. This side is x, so that is 6. So both QM, which is the bottom side, and HM, which is the vertical side, equal 6 inches. Okay. All right, over here we have our 45 degree over here to complete that triangle. So now that means that this side is x, this side is x, and this side is x radical 2. Now really, labeling those is really important because just because you see a radical does not mean that that's the side with radical 2. Just because it doesn't have a radical doesn't mean it's like the x side. Okay, so you really got to pay attention there. That's why it's important to pair these guys up. So if you look here, this is the side I'm going to focus on first because I know that it's 5 radical 3. I also know that it's equal to x, so I know x equals 5 radical 3. Okay, you take those two, set them equal to each other. In this case, that means x is solved for, so I can just go through and say that means this side is also 5 radical 3 because they have to be the same. But then my hypotenuse is x root 2. Well, I know x is 5 radical 3, and now I need to multiply that by root 2. So remember, you multiply outside by outside, inside by inside. So this 5, there's actually a 1 there, right? But 5 times 1 is still 5. And then the 3 times 2 can get multiplied together to be 6. Now 6 is not something that I can simplify, so it's just going to stay as 5 radical 6. So just because it's a hypotenuse doesn't mean it has to end in radical 2. Okay, that's just to build the relationship. So that means side DB is equal to 5 radical 3 centimeters, and BV is equal to 5 radical 6 centimeters. Okay. All right, down for number 4. Again, you really want to pay attention here to the placement of the angle measures and then labeling those sides, you don't want to rely on this because this is 45 down here, which means this side is x and this side is x as your two legs, and this side is x radical 2. So even though it doesn't have a radical 2 in it, doesn't mean that it can't be the hypotenuse. So just pay attention to that, because by knowing that, I now know that my x radical 2 side is 19. So I'm going to set x radical 2 equal to 19. Well, then in order to find the other two sides, I'm going to have to solve for x. So I'm going to divide both sides by radical 2. So that tells me that x equals 19 divided by radical 2. We know that we need to rationalize that. So I'm going to multiply numerator and denominator by radical 2. And I would end up with 19 radical 2 over 2 when I do that. 19 and 2 don't reduce, so it's just going to stay that way. So that would mean that this side is 19 radical 2 over 2, and so is this side. Okay, so both WF and FA equal 19 radical 2 over 2. I know it's ugly, meters. Just leave it like that though. Okay. All right, over here, if that's 45, so it's this, making this x, and this x radical 2. So again, just because the side that I'm given right here has a radical 2 in it does not mean it's this side with the radical 2 that I labeled. So what this actually means is that I know that x is equal to 7 radical 2 from that yellow side. So that means that this side is 7 radical 2 because it's also x. And then I have to substitute in. So I'm going to take my x value and I'm going to substitute it in right there. So that x radical 2 side is 7 radical 2 times radical 2. Well, radical 2 times radical 2, obviously from rationalizing, you've seen it. If you need to see it again, that means that this would be 7 radical 4, but we know the square root of 4 is 2, so this is actually 7 times 2, so that hypotenuse is 14. Okay. So PE equals 7 radical 2 feet, and PC equals 14 feet. Okay. All right, last one here. My other 45 is down here. I have x, and x radical 2. Okay, the side that I'm given is this hypotenuse right here. So if I set those equal to each other, I know x radical 2 is equal to the square root of 18, which isn't simplified, but that's okay. Because the first thing I'm going to want to do is divide both sides by radical 2 so that I can solve for x. So these go away. These are both inside a radical, so just like I can multiply them, I can also divide them. The square root, you don't need to rationalize here, you guys. This is a square root, this is a square root. So because like over here on number 4, I can multiply square root of 2 times square root of 2, 2 times 2 is 4, yada, yada, yada. Same thing here. So the square root of 18 divided by the square root of 2, that you can look at as the square root of 18 over 2. That's only if they're both in a radical. So that means this is the square root of 9. Well, the square root of 9 is 3. So that means that this side is 3, and so is this side. So both legs, both LN and LX equal 3 millimeters. Right? And we don't need to simplify that 18 because I'm not asking for it. So if you're a steps person, I always go through, the first thing I do is label the sides using the relationships. And by that, I mean that's when I do the x, and x root 2. And then the next thing I do is solve for x. Obviously, sometimes that's easier than others. And that's with the given side. And then I use that x to find the missing sides. So sometimes step 2 is easy because the side you're given is x, but sometimes step 2 you need to do some work before you can do step 3. All right, so the last thing we're going to do is kind of take away the picture and really focus on the relationships. So the biggest thing that we want to notice here, it says you fill in the chart using the picture to the right. So if you look, this is also 45. So that means this is my x side, this is my x side, and then this side is my x radical 2. So I'm going to come over here on the left-hand side. This side is my x, this side is my x, and this side is my x root 2. Okay, so I have 5 different triangles. Okay, triangle 1, 2, 3, 4, and 5. So I'm just going to do this 5 different times. The hope is that you can kind of do it quicker. Obviously, feel free to pause the video and see how you do with it. But if you look at this first one, this is saying, okay, what if the side was 8? Then what would you go through and do? Well, if A is 8, then B has to be 8 as well because they're both x. That means x is 8, so this side is 8 radical 2. For the next one, side B is radical 2. So whatever side B is, side A is. So that's also radical 2. For side C, that's just going to be radical 2 times radical 2 when you substitute this in for x. Well, radical 2 times radical 2 is the square root of 4, which is 2. For the next one, you're given side C. So that tells you that the x radical 2 side is equal to 11 radical 2. So if you go through to solve for x to find the a and b length, you're going to divide both sides by radical 2. Cancel those out. Over here, x equals, these are going to cancel out 2, and x is 11. So a is 11, and so is b. For the next one, we are told that the x root 2 side is equal to 12. So in order to figure out sides a and b, I need to solve for x. So I'm going to divide both sides by radical 2. So x is 12 over radical 2, and then I'm going to have to rationalize that. So a lot of this is just your algebra. That's really the timely part of these problems. You end up with x equals 12 radical 2 all over radical 2 times radical 2. We've done that a bunch. That is radical 4, which is just 2. Now in this case, you guys remember you always ignore the radical, but the 12 and the 2 can reduce, and you end up with 6 radical 2 because 12 over 2 is 6. So then you can come back up here and say this side is 6 radical 2, and so is this. Okay. Last but not least, if A is 5 radical 7, so is B. And then we're going to take that and substitute it in for x. So we have 5 radical 7. Oops. Let's try and write the right number. 5 radical 7 times radical 2. So this is your x root 2. Okay. And then the 5 is going to stay a 5, but then radical is going to get multiplied together. 7 times 2 is 14. There is not a perfect square in 14. So then this side is 5 radical 14. Okay, so that is how you do 45, 45, 90s. Obviously, if you have questions, please reach out. But these 3 steps not only are they going to be what we use for the 45, 45, 90s, but for the second relationship, we'll use those same steps. They just have different relationships in that, other than the XXX radical too. Okay, so definitely practice that homework tonight and let us know what kind of questions you have. Okay.